And you might want to say let w equals to x plus 2, and the x-axis now becomes w-axis. And that is just a simple example, right, to challenge you, to challenge your understanding of what you mean by random variable. Because if you kind of get sloppy with it and think of it as just another algebraic variable, it's not going to work. It's just not going to work very well or at all in many cases. So think of it as a histogram, as a diagram, right? In this case, the y-axis is the probability, frequency, relative frequency. Remember, we talked about that. So they're one and the same. And the x-axis is just the unique values of x, the sample space of x. Okay, so in this chart, if you forget everything, the most important line, I think, is here. That you should think of them, at least conceptually, all right, conceptually, as one and the same. Now, of course, one can always point out, wait, histogram is the chart. When you say histogram, one must think of a gram, a diagram, a graph. When you talk about random variable, one doesn't have to think about a diagram. And that is right. But that is precisely when, if you're a beginning learner, the the invisible bridge breaks down. Okay, so I'm trying to re-establish this bridge, because when you are already an expert and master, of course you can be very critical about the fine aspects of the differences between the two, but really it helps a lot when you think of them as the same. Okay, so if you can absorb that much, that's nice. But let me put another aspect onto this slide, and that is, can random variables represent population, or do they represent sample? The sample measurements. In other words, is this bag of data, this bag of measurements of the weights of apples, is this bag of data a sample or population? What about distribution? What about histogram? Yeah, so we are going to talk about these right now. So to change, let me change to another color just to emphasize. So in short, random variables can be used to represent population or sample, and it's fine. Okay, think of random variable additionally as a column of your Excel spreadsheet. One column, one random variable. And it's pretty much the right way to think about it. Okay, so if you have x1, x2, x3, you will expect your Excel spreadsheet to have 3 columns, x1, x2, x3. If you look at an Excel spreadsheet and you see 5 columns, x, y, z, p, and q, then your mathematics side of it, you will expect 5 capital letter random variables, x, y, z, p, and q. And they're one-to-one, and so it's pretty nice. Then the question is, but do they represent population or sample? Now, because by construction, random variables can represent population or sample, what this means is that you must query the question, whether it's your boss, your supervisor, your manager, or if you're a student solving problems and exams, examine the problem even more to sieve out information. Is the question hinting to you that X, right, without clear description, is X a sample or a population? So you need to read through the lines. Something like, John decided to survey his apples. He's not sure if he's being cheated by the Apple Store, and he likes to make sure that his apples are of enough weight. And so he randomly selected a few apples and he weighs them and he etc. etc. So this whole description of the activities of John randomly selecting apples, and that has to be a sample subset of the entire population or huge lorries of apples that is being sold at the store, right? So that will imply that X is a sample, and that's fine. X can represent a sample of measurements. On the other hand, John is trying to um, analyze the entire weight distribution of the apple of his, French apple yard and all the apples in his plantation. So that is beginning to describe the sense that John wants to know the entire population of apple weights, right? And then he says, let X be the entire, be the weight of apples. So even though there's no mention of population or sample, the whole description and activity and this John's orientation is basically thinking about X as a population, even though he hasn't collected the data yet. So yes, we can use random variable to mean population of data or sample of data. How to know? Scrutinize the question further. Then what about distribution? And what about histogram? Okay. Now, the easier one first. Distribution, whenever we use the word distribution, it has to imply population. Phew, that's one heavy weight off. Okay, so whenever you see a question, someone talking about, I've just analyzed the XYZ distribution. Oh, okay. I think you are trying to say that you have assumed that you knew about the entire population called XYZ. Okay, so the meaning, the hidden meaning, the implied meaning is that when you call a chart a distribution, it means you have understood the entire population, because all the probabilities, all the frequencies, all the relative frequencies add up to one. Okay, all the information, all the frequencies add up to one. Just now I was saying 1 over 9, 2 over 9, right? So if you add up, it's 9 over 9, and that's 1. So distribution implies population. No other way, all right? You cannot use the word distribution when you are actually analyzing samples. Cannot do that, okay? Because samples don't represent the entire population. They're two physically different things. Sample is a subset of population, right? So distribution must imply population. Histogram is a little bit like random variable, okay? So it can imply a population because you actually have measured all the items and then you plot a histogram. Or more commonly, we didn't. We just have a sample measurements and then we plot out histogram nevertheless. And that is entirely doable, isn't it? Just like we have made some measurements in Excel and we tabulated them, and we can start inserting, bar charts and histograms directly and immediately, even though we don't know the whole population of measurements. So histogram, when you see one, interrogate the question further. Verify whether that histogram that you are seeing represents population or sample. Right? So similar to X. When you see an X, a random variable, appearing in a question, interrogate the question more. Is the X trying to mean sample or population? Now, this is important because what it means can lead to different applications of different formulas. If you're asked to calculate variance, there's a difference between sample variance and population variance. If you're asked to calculate standard deviation, coefficient of variation, all the related parameters, there's slight differences between the formulas of sample-oriented kind of computations and population-oriented computations. So one has to be really clear. And of course, most importantly is that we need to understand completely what the author of the random variable or the histogram or the distribution is trying to say. So the clearest is therefore distribution, right? Someone saying distribution must mean population, but otherwise, if it's histogram, if it's random variable, this is when you must be alert and start finding out more, all right? If you are the one producing a distribution, then you better be sure you are talking about population. If you are the one drawing a histogram, better be clear, right? That, the above is a histogram of our sample survey, yeah, something like that, so that you are very clear that it means a sample. Oh, the above histogram represents all our measurements of the class of students that we are trying to study, their heights, their weights, whatnot. Yeah, so that means population. Same thing, if you are the one writing down random variable, then be clear whether you are talking about X as population or sample. Now, there is also another kind of interesting link between them. When we say let X be a normal distribution, let's say, right? So the way to write it is let X be following normal distribution. So the tilde just means X has this shape that follows exactly normal distribution, which must follow a strict mathematical function to describe the heights. So let X follow normal distribution. So now, is X a population or sample? Well, remember, let X follow normal distribution, and that's a distribution, right? So it has to be a population. And if it is a population, and since X follows a population, the shape of a population, then X will have to be understood as a population. So this is how kind of like the whether is it population or sample gets inferred from statements like that. And you will get to see this a lot, right? In your problem solvings, your exercises and exams. Let X be a normal distribution of this mean and this standard deviation and so on. Right? So just so you understand, and this is the way we analyze the problem.